So, hi everybody, my name is Attila Marosi and I work for Sophos as a senior set researcher. This is my fourth time in DeepSec, which is not a coincidence, and I'm very happy to have me and to be here again. I like this conference so much. So, let's start it. Where should I host my malware? It's a question. I think you get this all the days. It's something you have to solve every day. Agenda: collect FTP server IP addresses, which could be very useful. But first of all, we have to discuss one thing: why this research was taken and why it could be interesting FTP server today, and why we did this research. There is a malware which called Malminer C, which is not a good one, not a fancy one. It's a very dummy one, but it used FTP servers, open FTP servers, to spread itself. Used something which was seen previously in a little bit different way, and it can earn very good money, and it can produce very good money. And in this case, we have the ability to monitoring not just the malware, but the money they can produce with it. So it's a little bit different and unique case, so it's worth to present, I think. We create a scanner, a tool to monitoring the network and some things on the network and some properties and some IP addresses and services like FTP. It's called Scanner. I will introduce this framework, how it works, and then speak about the result, what we found, and some scary cases we also found. So, scanning. If you thinking about and want to scan a dedicated service in an entire internet, you firstly had to find the IP addresses which points to the dedicated service. So you can create a network scanner, or you can use a service which already exists. I didn't want to scan the entire internet, so I wanted to leave this overhead behind and using already working and good services like Shodan and Census. The difference is based on the price of it. Census is supported by Google, and it's hosted in the University of Michigan, and if you would like to use, you can use it for free. It's a very good service, I think, so just give a try to it. So that was the first point. I used the Census to get the good candidates, the IP addresses which maybe have an FTP server, so maybe have a FTP server behind the IP address. So how the process could look like. If you have a IP address and a set of IP addresses to test, the first thing we would like to test that, okay, it's a FTP server or not. If the port is open, tries to log in with anonymous users, and if you have this chance and you were able to log in, check the write access on the disk and with the anonymous users, which is not a good thing. So if anonymous users has the ability to write to the disk and modify the files, it's not something you can expect, and it could provide an ability for malicious actor to use that storage and use that service to storing malicious data and to spreading malicious stuff. So, and this process continued with collecting the information about the IP addresses and then process it and analyze it. So that was the first idea. Then we had to figured out how to speed up this process, because it was very difficult to get the things, do the test, and collect the data. So then we developed a system called Scanner, which has the ability, you can pop up a question. In this case, in this situation, the question is that give me all the IP addresses relating to FTP services, creating a module which perform the things I described, just test the port 21, tries to log in with anonymous users, tries to create a folder or something to check the write ability on the device and tick it. It's done, next. So that's the framework. It's a very dummy one, but it's a very powerful one. So it's let us to test a certain services for some cases, and you can create modules as you would like, and just put it to the system. So then check and speak about the results. From census, we got 12 million IP addresses relating to FTP services. So that's the whole set of data. But we didn't want to test such a big data, so we decided to test the 1/3 of them, so just 3.5 million of IP addresses in this way. The result is something like this. So the 91% of the FTP servers are restricted, which is good, because only the users who has credentials, right credential, can use the service. But there is 9% where anonymous login is working. Mostly there are repositories and publicly available stuff, so it's not something malicious or you should care about or something. And there is 0% when you have write access, and how it's look like in a map. So in this data set, that means that there is 10 key FTP service where you can host your malware. You can host and write anything to the disk and to the service, because you have the ability with the anonymous user. In a heat map, it seems like this. So you can see that which locations are mainly involved with this. The scanner used just the 3.5 millions, but if you use this data for the 12 millions, that means you have 37 key potential IP address and service where you copy your instance and your malicious data, or just use it as a very big and very stable cloud storage, because you can copy everything to everywhere, and some of will be available tomorrow. So it could be used for that purpose as well. So I think it's much bigger number than we originally expected. We thought that there will be a couple of, but I think it's much more than a couple of. So, but what the situation and what the state of the device where you have to write access. In this story, we tracking the malminer C, and we saw that the 71% of the device where you have write access is already infected, already hosting this malware. And this malware is not so clever or something. It just randomly can generate IP addresses trying to log in, walking through the all folders and every places and copying itself. That's a very simple one, and I think, and according to the research, this is the only one which do the same thing. So it's just one malware, one actor who did this. So, but the whole set of data, the whole internet where anonymous user has a right access is infected with this malware already. So then we just wanted to check that what is the purpose and what kind of device are behind this set of data, and then which product mostly involved with this. And we found Seagate Central, which is a NOS device. You can use it at your home, and with the Seagate Central, the problem was a design flaw in this situation when Seagate provide not very sophisticated, but a sophisticated way to create users. With users, you have login credentials and passwords, and you can protect your data and separate the user in this way. But out of the box, there is a public folder, and the public folder can be write and access with an anonymous user. And if you would like to exchange data between the users, the only way is to put the data in the public folder. Many of the services of this device is working only just the public folder. So if you would like to stream your home media or something like that, you have to use the public folder. And if you open the device to be able to remotely access it, you won't be able to select from the user. So not only open for yourself, but open the anonymous user as well, and anyone can access the device. So the result was that yeah, it's a free cloud could be used, and there are so many personal data on that we didn't analyze or dig into, but it can be easily checked that yeah. The media is just bubbling about the ransomware, so you have to back up your data somewhere. NAS is a very good place to back up your data, and the NAS could be good for download all the stuff and just use this data for other purposes. So it's a scary stuff. The other vendor, we found Lassive, which used the same component because Lassive was bought by Seagate a couple of years ago, so they just reused the component, and that's the reason they also involved in this way, and they are 70–80% infected with this malware. Okay, what if you log into a Seagate Central? What will you see? If you use FTP and just log in, changing to the public folder, which is a basic folder, you will find a record. As you can see, the photo S here, or image zip, or EMG, XZ, or something like this. And this is the malware itself. And now a couple of words about the malware, how it looks like. You will see that it's a very sophisticated one. So C, miner C, it's a miner. If you have experience, a couple of years ago there were so many mining malwares which tries to use your PC to mine some kind of coins, mostly bitcoins, to get money and to exploit your system resource. But a couple of years, the difficulty of the mining was dramatically increased, and it wasn't a good business on that time to use a personal PC to mining stuff. But currently there is a new cryptocurrency called it Monero, and the difficulty of the Monero is much less than Bitcoin. So someone just figured out that, okay, that PC is originally not good for mining Bitcoin because the difficulty is too high, but this new money has much less difficulty. So get the code again, use these techniques again, and create and earn money in this way as a couple of years ago. So MoleMiner C is a NSys application, an MC script. I think it was developed roughly a couple of hours or maybe a couple of days, but it's not so sophisticated. Bringing just stock applications, put all the applications to the auto run, and grabbing a couple of hashes to provide the miner, which wallet will be fed with the money, and that's all. So that's the application, and it has another component which I will be describing. How the original concept looks like: if there is a infected machine, it tries to log in to a randomly generated IP address. If there is a FTP service, it tries to write the malicious content to the disk, and it's hoping that the NOS, the device which was just infected, is behind a NOT or used by a Windows PC, and someone will store the application because the application has a folder icon, so you can get confused browsing your data, and there is a folder which has there is a application which has an icon as a folder, so you can easily get confused and store it in your inside network, and you just get infected with this malware, and then your PC will mine the Monero currency, and also trying to scan the network and copy itself somewhere else. So it's a very basic concept to spreading something, a malware, but as you can see, it's working very well. So the application I mentioned, the TFTP exe, as this application, this component of the malware, just scanning the internet, and if it was able to log in to a server, it's copying itself to the folder and tries to infect all the HTML, PHP, and web-related files, because if that service providing HTTP services, maybe the user will be infected in that way. So just trying to infect the HTML and web-related file with the iframe, and if you open the malicious website or the infected website, the info zip just get downloaded as a iframe component, and you could be infected. It requires some user interactions, but if you are very keen, or some user are very keen on to get the content they desire to get, they get infected in this way. So, okay, this application is using your PC to mine Monero currency. What makes this story interesting, that Monero pool is an open pool, and if you have the hashes, which is a user ID, you can get the information about the activity of the user. So with the malware, we can get all the hashes they use to generate the money, to mine the money, and if you have these hashes, you get the backlog of how much money they earn, what is the power of the network of the infected machines, because you can track all the things by this website. So we did it. We get all the hashes, extract from the script, and then we were able to check the Monero web page and iterate over with the hashes and gathering all the information, how much money was paid with that ID, what is the hash rate, so we can accumulate all the values, so we get the full power of the infected machines. So it's unique. We haven't found something like that. We get the exact number of the money they earn with this. When I made the calculation, the Monero cost less than 2 euros. Currently, it's more than 5. So it's now, if you have this amount of Monero currency, you have much more. So it depends on the exchange. But on the day I made the calculation, that was the number. So if you measure it with coding just a couple of hours, maybe days, using such a dummy way to spreading malwares with open FTPs, just copying them and using stock mining component, you have no development costs or something. It's a good money, I think. So they do, they or he, she, I don't know, did a good thing. No. So my favorite, these were nashes, which belongs to home users, and maybe it's problematic but not dangerous. But there are other vendors and other devices which not just interesting but could be very dangerous as well. So Netvu, it's a UK company, and this device is used to observe and monitoring stadiums and big buildings. So it's not your child monitor. It's a bigger, much bigger stuff. It's a CCTV aggregator thing. If you use Senses to get the right device, and if you know how to search it, you will find something like this. If you check this, the first is welcome to and the username, and the second is command line, and it's a prompt. So if you have a good question, the answer will be the device which has a username set it, and it's not working with the default settings, and the second is used by the default settings and putting to the internet, and anyone can use it. Okay, how many devices are there on the internet currently which is working and you can use it with basic settings? Roughly 1 key. And if you log in with Telnet, you can get all the features they provided. So you can do whatever you would like to do with this device in this way. But if you log in with FTP, you can see that other actors already trying to abuse. They didn't know that this device, what's purposes or something. They just scanners and login, copying, creating stuff, creating files, and that's it. But as you can see, the symptoms of the tryings is already there. Malminers is already there, and which is very scary in this situation. Web interface and firmware related stuff are there, and if you check it and take a closer look, you will see that in that folder all the things, all the web UE and component and everything which good and required to control this big stuff is there, and anonymous user able to log in and modifying, downloading. So with anonymous you can update the firmware anytime. So in a map, as you can see, it's a UK stuff and mostly used there. And 80% already infected with -C, but in this situation, not -C is the interesting part of it. These devices could be easily pawned and could be used for other purpose, not just to hosting malware or infected someone, but just imagine. So the next one is I had to cover the vendor because for me it's too scary. So these the devices, as you can see, it's not for home users. It's to easily create SCADA stuff. So you can buy these gadgets. You can create something which could be very good for cities or big companies. You can link together the devices. You get a controller. You get many sensors, and they provide you a very, very easy and common way to control it. You will see it, and you can create very, very fancy stuff. Light shift is something like this. So they use this this solution, this component. They bought this and putting sensor to the light. There is a controller. You can control the lines of as you would like to by the street light or something, and you have a web management interface and create something like this. If you use it without changing the default settings, that means the device can be controlled by anyone. There is no login question. There is no basic login credential or something. If you know the IP address, you can log in. If you can log in, you will be able to do anything with the device. And the things I mentioned, the easy way and common way to control and build a very powerful SCADA system is a Python. All the gadgets had a Python inside, and with Python scripts you can create a very fancy SCADA stuff. So the only thing you can do, create a Python script as you usually do, upload it, and you have a device in a purpose you would like to. So as you can see, there are already on stock file there, but that's the interface. You can upload a Python script and you can start it, and it will use the research and everything on the device. As you can see, there are others who tried already hack the device, but they didn't know that it works with Python, not PHP. So almost. But also, if you use census and search with a good string, you will get roughly 2.5 key devices, which could be used in a purpose you would like to, if you are able to write a Python script. But okay, take an extra step and check the config data and check the GPS information and just figure out that, okay, these devices control lights and we have the cell information about it. Just put it together and check. Maybe these lights are controlled, and if you would like to rob something or do some dirty things, That's one point you can check, and you can turn the light on or off, or using in. So it's scary, I think. So the conclusion, for me, the 0%, the thing I knew that I expect that there will be a couple of devices which anonymous user can create and modify files, but I didn't thought that and didn't expect that there is roughly 40 key devices and IP address which could be involved in such a way. For normal users who just use these devices, I think there is not so much they can do. It's not a fault of them or something. They just have to encourage and push the vendors to create a better solution and better things. They pay for the devices. So if we speak about these network stuff, you have to push the vendor to get and do the best they can do. And for vendors, I think it would be nice to push them and encourage them to make some audit and not selling solutions and devices which anyone can say that, okay, if you put it to the internet in this state, that will be a big fault, so don't do that. So thank you. Before question, I have been presenting a couple of years, and it was more than 60 presentation of my me, but it's very special for me, maybe a little bit influenced it, but my father is here, and I would like to say thank you for my father to supporting me in all my life. Thank you. So, questions?
So thanks for the talk. Maybe I missed it because I was outside for a little while, but did you mention whether or not you've observed any major malware campaigns, common, normal, not device malware, so normal Windows device malware being hosted on such cloud storage networks?
No, but there are so many very interesting things or files, or I don't know currently what they are. There are devices which has random file names with random data, and you have no information what those are. So it would be nice to track and monitor many of devices. Currently, we do not tracking these devices, so not downloading the files and checking again. Maybe that will be solve this problem or provide us some information. But in our data set, there are so many devices which just has very interesting files, which I think not belongs to the users or some service.
I see. Maybe for the devices you can execute stuff on, have you tried pulling hashes from these files? And
no, we didn't execute something.
Okay, I see.
So we just
makes
checked.
sense.
Yeah. So in this case study, more minor C is not. maybe the infected is not a good expression for it, because they do not infect the FTP service. They use the FTP service to copy an instance to the server, and someone has to start it and then get infected. But it's a very good point to be infected.
Any other questions?
Did you detect any phishing campaigns that might lead someone to actually start the minor C? You know, like with a link local or something like that?
Yeah, at the beginning there was a couple of, but maybe they just were too, they wanted to use that way as well, not just copying itself through the FTP service. But it seems they were, that was enough for them, because there was just a couple of at the beginning, which was roughly 1.5 years.
Yeah, thank you for the talk. How many devices did you find to be hacked, but like there was an executable, but it wasn't? It was for the wrong system. It was PHP and just used
Some trying, sorry.
So just automated exploitation and trying to host malware. How often was it? How often did you encounter that instance?
Yeah, so 71% is already hosting this malware, and there are so many which hosting such a P99 PHP or something. The problem is we have roughly 20 gigabytes of data set and 3.5 million of IP address with this very big data set, and the tryings and the malwares we would like to test is very, there are so many. So if you find this P99 PHP, you will get roughly 100, and then you have to check for another one and another one. So there is no, currently there is no list about seeking malware's actions or symptoms. So it's very difficult to say. But in my personal experience, roughly on 80-90% has some touch. So they were tried, but there are so many type of trying. So that makes it difficult to measure and get a final number that, yeah, that's the real number of the touching.
Okay, thanks.